So again, our calculator is going to make figuring out these binomial model probabilities really easy. But in order to use it, we have to check that the situation is appropriate for a binomial model. So in order to use binomial model, we need all four of these features. So I'm going to talk about them one at a time, and then you'll practice figuring out when we can use them and when we can't. So the first thing that we need for this to work is a fixed number of trials. And we represent that fixed number of trials with the letter N. So we might be doing a problem where we flip a coin 10 times. So N equals 10. In the last problem, the one with the dogs, we were looking at 3 students. And for each of those students, they could either have a dog or not have a dog. But in that case, those 3 students were our 3 trials. So N would be 3 in that situation. The next thing that we need is that there are only 2 outcomes. This doesn't work for more complicated situations. We refer to these 2 outcomes as success and failure. It doesn't actually have to be something that where one is positive and one is negative, but we think of one of them as being successful, we have met a requirement, and one isn't. So, for example, having a dog, I think it's a great thing, but it's not automatically a success. But because there are only 2 outcomes here, dog and cat, we can think of this as being successful. Another example we might think about is if we were flipping a coin. Our 2 outcomes might be heads or tails. And we would just label one of these as success and one of these as failure. Now, we could have more complicated situations, like maybe if I'm thinking about pets, someone could have a dog, someone could have a cat, someone could have a dog and a cat. Someone could have no pets. I've kind of run out of room for birds and lizards, so we'll just stick with this for a second. If I wanted to use a binomial model here, I would have to simplify this. And I would have to say, you know what, if they have a cat of any kind, I'm going to call that a success. So cat would be a success. And that would mean that these other people, the people who either just have a dog or the people who have no pets, they would get lumped into the no cat category, which would be a failure. Okay, so if you have a more complicated situation, sometimes we have to narrow it down so there's only those 2 outcomes. The next key feature we need to check for is that the probability of success is the same at each trial. We represent this probability with the letter P. So for that coin flipping example, the probability of success, the probability of heads would be 50, right? And that's not going to change from flip to flip. Every time you flip that coin, you're going to have a probability 50% of getting heads. If I think about the first problem that I did, what's the probability that someone has a dog if that's successful? That was 40%, right? 0.4 for the probability. And that's not changing as I go from student to student. So if the probability does change in the middle of my trials, we can't use the binomial model. The last thing that we need, and this is kind of a big one and a little harder to check, is that the trials need to be independent. So the outcome of one trial shouldn't affect the other trials. So in the example with the students in my class, probably those students don't know each other. And so or Alice having a dog probably doesn't impact if Bob has a dog, which probably doesn't impact if Carl has a dog. So we're probably okay assuming that the situation is independent. Same thing with the coin flips. One coin flip doesn't impact another. But if the class that I was teaching was a veterinary class about dogs, right? So if teaching a college course for vets specifically, then those probabilities might not be independent. Maybe they all have dogs and that's why they want to be vets. So these are the kinds of things we have to think about. And remember, we need all four if we're going to use our calculator to do these problems. So we need a fixed number of trials. We know how many people or how many trials we're looking at the very beginning. We need there to be only two outcomes, and we might have to narrow it down to get to those two outcomes. We need that the probability of success isn't going to change from trial to trial. It's going to be a fixed number that's going to be the same for everybody. And we need that those trials are independent.